When sizing a rigid metal conduit for fill with tray cable, there are a few key steps to follow. Firstly, calculate the conduit fill. This involves determining the cross-sectional area of the conduit and the tray cable. To do this, firstly, measure the cross-sectional dimensions of the conduit. Secondly, obtain the dimensions of the tray cable, including the number and diameter of the conductors. Then use the following formula to calculate the conductor fill percentage. Conductor fill percentage % equals tray cable cross-sectional area / conduit cross-sectional area x 100. Secondly, check the fill limits. For tray cable installed in metal conduit, the fill limit is 70% of the conduit cross-sectional area. Thirdly, calculate the conduit size. If the conductor fill percentage is less than or equal to 70%, the conduit size is adequate. If the fill percentage exceeds 70%, a larger conduit size is needed. Regarding derating ampacity, according to NEC Article 392, tray cables are not required to be derated for ampacity in metal conduit, unless the conduit contains more than 90% of its total cross-sectional area. Here's an example to illustrate the process. Given a tray cable with 3 number 1 conductors and 1 number 6 ground conductor, and a 1-inch rigid metal conduit, let's determine if the conduit size is adequate and if ampacity derating is required. Firstly, calculate the conduit cross-sectional area. Assuming a 1-inch rigid metal conduit has an inner diameter of approximately 1 inch, the radius is 0.5 inches. The cross-sectional area is then calculated as pi times r squared, which equals pi times 0.5 inches squared, resulting in approximately 0.785 square inches. Secondly, determine the tray cable cross-sectional area. Assuming each number 1 conductor has a diameter of 0.25 inches and the number 6 ground conductor has a diameter of 0.125 inches, the conductor area is calculated as 3x 0.25 squared plus 1x 0.125 squared, which equals approximately 0.1875 square inches. Thirdly, calculate the conductor fill percentage. Using the formula 0.1875 square inches / 0.785 square inches x 100 equals approximately 23.91%. In conclusion, the conduit cross-sectional area is adequate for the tray cable as the fill percentage is below the 70% limit. Therefore, no ampacity derating is required. To reiterate the steps, firstly calculate the cross-sectional area of both the conduit and the tray cable. You'll need the dimensions of the conduit and the diameters of the conductors within the tray cable. Use the formula pi times r squared to find the area of the circular conduit, where r is the radius half of the diameter. For the tray cable, calculate the area of each conductor using the same formula and sum them up. Secondly, determine the conductor fill percentage. Divide the total cross-sectional area of the tray cable conductors by the cross-sectional area of the conduit and multiply by 100. This will give you the percentage of the conduit that is filled by the conductors. Thirdly, compare the fill percentage to the allowable limit. For tray cables in metal conduit, the NEC typically allows a maximum fill of 70%. If your calculated fill percentage is below this limit, the conduit size is adequate. If it exceeds 70%, you'll need to select a larger conduit. Regarding ampacity derating, NEC Article 392 provides guidance on this. Generally, tray cables in metal conduit do not require ampacity derating unless the conduit is filled to more than 90% of its cross-sectional area. This is a much higher threshold than the fill limit for conduit sizing, so it's less likely to be a concern in most installations. However, it's always crucial to consult the latest version of the NEC and local electrical codes for the most accurate and up-to-date requirements. Let's delve deeper into each of these steps to provide a comprehensive understanding. When calculating the conduit cross-sectional area, it's important to use the internal diameter of the conduit. This information can typically be found in conduit manufacturer catalogs or online resources. Remember to convert all measurements to the same units, such as inches, before performing the calculations. For the tray cable cross-sectional area, you'll need to know the diameter of each conductor. This information is usually available in conductor specification sheets or online databases. If the conductors are insulated, be sure to use the diameter of the insulated conductor, not just the bare conductor. Once you have the diameters, calculate the area of each conductor using the formula pi times r squared, where r is half of the conductor's diameter. Then sum up the areas of all the conductors in the tray cable to get the total cross-sectional area. When calculating the conductor fill percentage, be precise with your measurements and calculations. Even small errors can lead to significant differences in the final result, which could affect the safety and compliance of the installation. If you're unsure about any of the calculations, it's always best to consult with a qualified electrician or electrical engineer. Regarding the allowable fill limits, the NEC provides specific guidelines for different types of conduit and wiring methods. For tray cables in metal conduit, the maximum fill is typically 70%. However, it's important to verify this information in the latest version of the NEC and any applicable local codes. If your calculated fill percentage exceeds the allowable limit, you'll need to select a larger conduit size. This will reduce the fill percentage and ensure that the installation complies with the code. When choosing a larger conduit, be sure to recalculate the conductor fill percentage to confirm that it is within the allowable limit. Regarding ampacity derating, the NEC provides tables and guidelines for derating the ampacity of conductors in various conditions. However, as mentioned earlier, tray cables in metal conduit typically do not require derating unless the conduit is filled to more than 90% of its cross-sectional area. This is because the metal conduit provides excellent heat dissipation, which helps to keep the conductors cool. However, if the conduit is filled to more than 90%, the heat dissipation is reduced, and the conductors may need to be derated to prevent overheating. To determine the appropriate derating factor, consult the NEC tables and guidelines for the specific type of conductor, conduit, and installation conditions. It's also important to consider any other factors that may affect the ampacity of the conductors, such as ambient temperature, grouping of conductors, and voltage drop. By following these steps and consulting the relevant codes and standards, you can ensure that your tray cable installations are safe, compliant, and reliable. Always prioritize safety and consult with qualified professionals when in doubt. Additionally, remember that the NEC is updated regularly, so it's essential to stay current with the latest requirements. Consider subscribing to electrical industry publications, attending training courses, and networking with other professionals to stay informed about the latest changes and best practices. Proper conduit sizing and ampacity derating are crucial for ensuring the safe and efficient operation of electrical systems. By taking the time to understand these concepts and apply them correctly, you can contribute to a safer and more reliable electrical infrastructure. Always double-check your work and verify your calculations before energizing any electrical equipment. Electricity can be dangerous, so it's essential to take all necessary precautions to protect yourself and others. And never hesitate to ask for help or clarification when needed. The electrical industry is complex and constantly evolving, so continuous learning and collaboration are essential for success. By working together and sharing knowledge, we can all contribute to a safer and more reliable electrical world. Now, let's consider some additional factors that may influence conduit sizing and ampacity derating. Firstly, the type of tray cable used can affect the conduit fill calculation. Different types of tray cable have different overall diameters, even with the same conductor size. Therefore, it's important to use the actual dimensions of the specific tray cable being installed. Secondly, the presence of other conductors or cables in the same conduit can also affect the conduit fill calculation. If there are other conductors or cables in the conduit, their cross-sectional areas must be included in the total fill calculation. Thirdly, the bending radius of the conduit can affect the allowable fill. Sharp bends in the conduit can reduce the available space and increase the friction on the cables, which can affect the ampacity. Therefore, it's important to follow the NEC guidelines for minimum bending radii. Fourthly, the ambient temperature can affect the ampacity of the conductors. Higher ambient temperatures can reduce the ampacity of the conductors, so it may be necessary to derate the conductors accordingly. Fifthly, the grouping of conductors can also affect the ampacity. When multiple conductors are grouped together, they can generate more heat, which can reduce their ampacity. Therefore, it may be necessary to derate the conductors if they are grouped together. Sixthly, the voltage drop in the conductors can also affect the overall performance of the electrical system. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Therefore, it's important to size the conductors appropriately to minimize voltage drop. Seventhly, the type of conduit used can also affect the ampacity of the conductors. Different types of conduit have different thermal properties, which can affect the heat dissipation of the conductors. For example, metal conduit typically provides better heat dissipation than non-metallic conduit. Eighthly, the length of the conduit run can also affect the ampacity of the conductors. Longer conduit runs can result in higher voltage drop and increased heat generation, so it may be necessary to increase the conductor size or derate the conductors accordingly. Ninthly, the presence of any splices or terminations within the conduit can also affect the ampacity. Splices and terminations can create points of increased resistance and heat generation, so it's important to make sure that they are properly installed and rated for the application. Tenthly, the presence of any other equipment or devices within the conduit, such as pull boxes or junction boxes, can also affect the overall system performance. These devices can create additional points of resistance and heat generation, so it's important to ensure that they are properly sized and installed. By considering all of these factors, you can ensure that your conduit sizing and ampacity derating calculations are accurate and that your electrical system will operate safely and efficiently. Remember to always consult the latest version of the NEC and any applicable local codes for the most up-to-date requirements. And never hesitate to ask for help or clarification from qualified professionals when needed. The electrical industry is constantly evolving, so continuous learning and professional development are essential for staying current with the latest technologies and best practices. By investing in your knowledge and skills, you can contribute to a safer and more reliable electrical infrastructure for everyone. Always remember to prioritize safety in all of your electrical work. Electricity can be dangerous, so it's essential to take all necessary precautions to protect yourself and others. Wear appropriate personal protective equipment, follow established safety procedures, and never work on live circuits unless you are properly trained and authorized to do so. By working safely and responsibly, you can help prevent accidents and injuries and ensure that your electrical work is of the highest quality.